Okay, next example with trig substitution. So, how you're going to recognize trig substitution is you have a square root symbol, okay, and it is not a direct substitution question. So in other words, the derivative of the inside is not hanging around. So I'm going to figure out a way to manipulate what's underneath here so that this will become a trig identity, a Pythagorean identity, so that I can eliminate what's going on. So it's x squared plus 4. So when I look at my identities, I'm actually going to use the identity tan squared plus 1. So I want to let x equal 2 tan theta. And hopefully it will seem obvious to you when I get to the point where I figure this part out. Okay, so I'm going to just do this little bit. So this is x squared, so 4 tan squared theta plus 4. It's what's underneath the radical symbol here, okay? So basically before we had one that was, I think it was 1 minus x squared. So I had to find an identity that was 1 minus a trig identity. Because this is plus, I needed to find something that was a plus. So I could have used tan or cotan in this situation. It would have worked out the same, but I just feel more comfortable with tan. The difference last time too is I had a plus 1. Here I have a plus 4. So what I need to do is manipulate it in a way so I can cancel this. So what's going to happen is I'm actually going to pull out the 4. So then I get tan squared plus 1. So then I get the square root of 4, and tan squared plus 1 is secant squared. And then it simplifies to this. Okay, so that was the whole point of doing this let statement, is so that I can manipulate it to get rid of the radical sign, okay? So what's underneath here is going to guide what you do for your let statement. If you see a plus, you're going to use tan or cotan. If you see a negative, you're going to use sine or cos, okay? And if it's a 1, you don't have to put a number in front of there. But if there is a number in front, you need to figure out what you're going to put here so when you square it, it's the same as this, so that you can factor it out and it will become a 1. Okay? So, now we're going to plug everything in. So, if x is 2 tan x, dx d theta is 2 secant squared theta. So dx is 2 secant squared theta d theta. Okay? And we have an x squared there, so we're going to go for there. So 1 times dx. So here's dx, 2 secant squared theta d theta, over x squared, so 4 tan squared theta, times this whole thing, which I worked out to be 2 secant theta. So my next step is going to be to do some simplifying here. So this 2 and this 2 are going to cancel. This, one of these secants is going to cancel with one of these secants. And because I don't like dealing with numbers inside of here, I'm going to take the 4 outside. So I end up with a quarter outside. I have a secant theta d theta on top, and I have a tan squared theta on the bottom. Now, I don't know about you, but I do not feel comfortable about integrating this. Like, there's nothing, that's not a straight up integral for me. So at this point, you might not know what to do. Try stuff. So I'm actually going to just try switching everything to sine and cos. So secant is 1 over cos, divided by tan squared, which is sine squared over cos squared. And then when I'm dividing fractions, I flip and multiply, so I end up with this. Okay, so then I'm going to cancel that with that. So I end up with a quarter cos theta over sine squared theta theta. And I've actually manipulated it into a u du situation. So u is sine theta, du is cos theta d theta, and fu is u to the negative 2. So I can do a quarter integral u to the negative 2 du. Okay? You know it's a good question when you need more than one board to do the question. Okay, so we're going to keep going. So a quarter u to the minus 1 over minus 1 plus c. So let's just simplify that. Negative a quarter u plus c. U, though, we're not going to put a u in the answer. U is sine. So I have 1 over 4 sine theta plus c. Okay, now we get down to a point where we have an answer. Having said that, my question way over here started with x's, and now I have thetas. So this is when I make my triangle. So I go right back to x equals 2 tan theta. let's just rearrange it. X over 2 equals tan theta to isolate for the trig identity. We're going to make a triangle. Okay, so here's my theta. So tan is opposite over adjacent. So opposite over adjacent. So then I figure out what goes here. X squared plus 4 square root it, right? Because a squared plus b squared equals c squared, but this is c, so we need to square root it. And then I'm going to figure out what's going on here. So this is the same thing as saying negative cosecant theta over 4. I don't know if that really matters, but we'll go with that. So we're going to have negative a quarter out here, and then cosecant theta. So cosecant is the opposite of sine. So sine is opposite over hypotenuse. So cosecant is hypotenuse over opposite. So I end up with this. Plus c, so minus the square root of x squared plus 4 all over 4x plus c. Isn't it beautiful? Good luck.